Alright, so today we're going to be talking about 116, system of linear inequalities. Alright, so systems of linear inequalities. So in a system of linear inequalities, the inequality sign does not allow us to perform substitution or elimination as we do with a system of linear equations. So in order to solve a system of inequalities, we turn to graphing. I'm going to write it in a second when my tab loads. It's taking forever. There it is. Graphing. The solution is the set of ordered pairs that satisfy all the linear inequalities. In other words, the region where they overlap. So I'll write that down in a second. This tablet, hang on. Where the shaded regions overlap. All right, is everyone ready to move on? Are we good? All right. So the first thing we're going to do is we're going to graph a system of these together. So the first thing you need to know before you graph them is you need to make sure that they are in slope-intercept form. As we talked about yesterday, are they in slope-intercept form?
Yeah.
Yes, they are. So I'm going to graph this one first. So that's going to be -4, 1, 2, 3, 4. And then I'm going to go up 1, 2, 3, and over 1, 2, 3, 4. Now when you run out of room, you can also backtrack, go down 1, 2, 3, and over 1, 2, 3, 4. And this one is going to be a solid line because there is an equal sign under the inequality.
Should we use different colors?
Yeah, so you're going to do one equation in one color and one in the other. So I'm going to shade below this line. Try to make my blue a little more like prominent because it was kind of light on the last slide. There we go. So I'm going to shade below this line because the Y is not being eaten by the alligator, right? And then we're going to do the same procedure for the other line. And we talked about this yesterday. Y equals a number or inequality a number. That's going to be a vertical line, right? So it's a vertical line through the Y value of -7. So 1, 2, 3, 4, 5, 6, 7. I'm sorry, horizontal. Why did I say vertical? Horizontal. 1, 2, 3, 4, 5, 6, 7. Right here. Horizontal line. So Y equals is horizontal, X equals is vertical. And we are going to graph it by putting a dashed line here. Dashed line because the inequality doesn't have an equal sign on it. Now, which region do we shade on this one? Above or below? Above because the Y is being eaten by the alligator. Good. So we're going to shade here. It's going to look like this. And let's talk about what each of these regions represent. So anything that's in the green satisfies just the green equation. Anything that were just blue, which satisfy only the blue equation, where they overlap is what satisfies both of them. Okay? So keep in mind, any of the values or coordinates in this region satisfies both, and anything on this line would also satisfy them both. But what about anything on the dashed line? No. So any point on the solid line is okay. Dashed line you don't want because it's a boundary, okay? So let's go ahead and try the next one. So first thing I'm going to need to do is I'm going to need to get this into slope-intercept form. So I'm going to start by rewriting it. Then I'm going to subtract x on both sides. that's going to give me negative 1y is greater than negative x plus 1. I'm going to divide both sides by negative 1. And when I divide by a negative, I need to do what with my inequality? Flip it. So this becomes a negative divided by a negative, which is a positive 1, minus 1. So I start on my y-intercept, and I go up 1 over 1. And I just repeat that process because that's my slope. And then I'm going to use a dashed line for my inequality, because there's no equal sign underneath it. And am I going to be shading above or below here? Why am I shading below?
Because it's eating the y.
Good, so see how here the alligator is not eating the y? So since it's this way, you shade below. You only shade above when the alligator eats the y. And then we're going to do the same idea for the other equation. I'm just going to move over a little bit so I have some room. So I'm going to rewrite the other equation. And I'm going to get it into slope-intercept form by subtracting x on both sides. That gives me 4y is greater than negative x plus 20. Divide both sides by 4. Remember, this is really a negative 1x. I didn't divide by a negative, so I do not need to flip my inequality. A negative divided by a negative would be a positive, but this is a negative divided by a positive, so it stays negative. And then this becomes a positive 5. I start at 5, 1, 2, 3, 4, 5. I go down 1 and over 4. And as you can see, we can't go this way anymore, so I'm going to go opposite, up 1 over 4. I'm going to then connect it with a dashed line. And am I going to shade above or below?
Above.
Good. Above. So this region right here where the colors overlap is what they have in common, what points they have in common, the two systems or the two equations. The white region is what neither of them have. The blue is what only the blue has, and the green is what only the green has. Does that make sense for everyone? All right, are we good to try another one? Okay.
Wait, do you shade above or below?
Oh, so the reason you shade above is when, think of this as like an alligator's mouth. When it eats the y, you shade above. When it doesn't, you shade below. Alright, so on this one, you're going to see that these are both not in slope-intercept form. So just to save the time here, I'm going to actually just tell you what those are in slope-intercept because we've been practicing it a lot, so I think everybody's pretty good with it. When I rewrite this in slope-intercept form, it becomes y is less than or equal to negative 7/3 x plus 6. And when I rewrite this one in slope-intercept form, it is y is greater than or equal to 2/3 x minus 3. So I just did the work for you there. Now once we have them in that form, but you will need to know how to do that on your quiz, of course, we're going to graph them. So I start at 6, 2, 3, 4, 5, 6, and I go down 7, 1, 2, 3, 4, 5, 6, 7, and over 1, 2, 3. And if you try to do it again, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, you go off the graph a little bit, that's okay. And this is going to be a solid line. And are we going to be shading above or below? On the blue one. Below, very good. And then we're going to do the one in the green. I'm going to start at -3, 1, 2, 3. And I'm going to go up 1, 2, and over 1, 2, 3. I'm going to connect these with a solid line because the inequality has an equal sign underneath it. And then I'm going to be shading that one above or below? Above. Alright. How's everyone feel with number 11? Pretty good? Alright. So the next one, we're going to need to obtain slope-intercept form for this. So to do that, I would subtract 4x on both sides. That's going to give me -5y is greater than -4x minus 5. Divide both sides by -5. When I divide by a negative, I need to do what? Good, change the sign of my inequality. A negative divided by a negative is a? Positive 4/5 x. What's -5 divided by -5?
1.
Good, positive 1. So I'm going to graph that by starting on the y-axis at 1, my y-intercept, and then I will be going up 4 and over 5 due to my slope. 1, 2, 3, 4. 1, 2, 3, 4, 5. Now since I ran out of room in this direction, I'm going to go the opposite. 1, 2, 3, 4. 1, 2, 3, 4, 5. Now I'm going to connect my dots with a what kind of line? Dashed or solid? Dashed. Because there is no equal sign under my inequality, okay? And which way am I going to be shading this? Below. Good. I'm going to fill this in. And then the other equation you'll notice is a, what kind of line is this? Vertical. So x equals a number or inequality with a number is a vertical line, and it's going to be at the x-axis at -1. And then we're just going to draw a vertical line through that value, like this. And then we have to think of which way to shade it. So if I'm talking about x values that are less than -1, are those going to be on the left or on the right? Left. Good. So any point in this double shaded region satisfies both inequalities. Anything in just the blue satisfies just the blue. Just the green satisfies just the green, and the white is neither. How's everyone feel about 1 through 12 so far? Good? Alright, so we're going to do 2 types of problems now from here. This first one is really important for your quiz, so is everyone ready? Does anyone need more time? Okay. Alright, so in this question it says which inequality or which points are solutions to the system of inequalities below. So the first thing we're going to have to do is we're going to have to graph these inequalities just like we were just doing. Now for the sake of time, I'm just going to tell you what these simplify to be. The first one comes out to be y is less than 1/6 x plus 8. And this one, when you simplify it, comes out to be y is less than -2/3 x plus 9. So now we're going to plot those just like we were before. We start at the 8, 1, 2, 3, 4, 5, 6, 7, 8. And we go up 1 and over 6. 1, 2, 3, 4, 5, 6. Down 1 over 1, 2, 3, 4, 5, 6. Now we're going to connect the lines with a dashed line because of the type of inequality there is. And now we're going to be shading it below because it is less than, right? And then we're going to do the same procedure for the one in the green. We start at 9 on my y-axis. Oh wait, it's not 9, it's 3. That makes more sense, yeah. When you divide it, it becomes a 3. So we start at 1, 2, 3, and we go down 2 and over 3. Down 2 over 3. And then we just connect that line with a dashed line. And then we're going to shade it below. Okay. So now we're ready to talk about what this all means. So you see these points over here? They want you to determine which of these points it satisfies both inequality system, okay? The whole inequality system. So let's look at our first point right here, which is 1, 1. Does 1, 1 fall in the double shaded region? Yes, it does, right? Right here. So 1, 1 is correct. Now let's look at negative 2, 6. So we go over 1, 2, and up 1, 2, 3, 4, 5, 6. So what do you think about negative 2, 6? Does that fall in the double shaded region? No, it only falls in the blue, which is not what we're looking for. It has to fall in both. 9, 2. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And then down 1, 2. Does that fall in the region? If it falls right on the dashed line? No. If you fall on a dashed line, that's not part of the inequality because it has to fall on either a solid line or in the double shaded region. So that one is a no. Does everyone understand that? Negative 8, negative 3 is definitely in the region, right? Because this whole quadrant is in the region. 3, 4 is up here in the blue. And negative 7 is down here, which is going to be good. So this is like a question I could give you on the quiz because we're not going to be physically graphing on the quiz because it's a test that's on a computer. I'll give you a picture and you have to interpret the graph. Okay? Yes?
So you only use points that are in like the blue?
Only points that are in where the blue and the green overlap.
Oh, okay.
Okay? Alright. So now we're going to talk about two types of special systems. So the first one is going to simplify to give me y is greater than x plus 3. And the second one is going to simplify to give me y is less than or equal to x minus 5. I'm going to graph these. 1, 2, 3. And this one has a slope of 1 over 1. They both do actually. So I go up 1 over 1. And then I connect these with a dashed line. Now the alligator is eating the y, so I shade above. Now for the other one, I start at -5. 1, 2, 3, 4, 5. And I also go up 1 over 1. And then I connect these with a dashed line. And the alligator is not eating the y, so I'm going to shade below. So now that we have this situation, let's take a look at it and see what we can figure out here. Will these shaded regions ever overlap each other? No. So this is what we call no shaded overlap, no solution. So you know how when we do linear systems, we talk about how parallel lines never intersect and those have no solution? It's similar with these, but the difference is there are some times where they're parallel and they do intersect their shaded regions, and we're going to see both of those examples too. So we're going to also look at one that does overlap like that. So does anyone have any questions about this so far?
Wait, shouldn't like the blue be like solid? Cause
You're right. It should be solid, huh? Thank you. All right. How's everyone feel about that? Good? And we're going to do the same thing here. We're going to graph both of these. -4, 1, 2, 3, 4. Down 1 over 1. Oops, wrong way. It's going to look something like this. I'm going to connect it with a dashed line. And we're going to be shading above because of the way the inequality is going. And then we're going to repeat the process with the second one. Start at -1, down 1 over 1. And we're going to shade below. Okay, so does this one have an overlapping region?
yeah.
Yes. So this is what we call middle overlap solution. And is there ever going to be any white part of this graph? If it kept going on forever? No, it's always going to be completely filled in. And only that middle section is going to be going on forever and ever with all the, all the points that it contains. So, how's everyone feel about this so far? You pretty confident with graphing? Okay. So, now we're going to do a word problem. So, real world problem. So it says, to raise money to attend camp, Alex is selling popcorn, and he's selling small popcorn bags, we're going to call small bags X, for $4 each. And large bags, we're going to call that by Y, for $6 each. And he needs to earn at least $300 to attend camp. He will also earn a badge if he sells at least 60 total bags in any combination. So, basically, we're going to set up our first inequality. So the amount of money he makes on selling small bags is going to be based on the price of a small bag, which is $4, times the amount of small bags he sells, plus the amount of money a large bag costs times the number of large bags. And that amount needs to be something to $300. What's the inequality that's going to go here? Good, greater than or equal to, because you're going to need to make more than or equal to $300. You can't have less. Now the other inequality just says he needs 60 bags in any combination. So all we know there is that the amount of bags he sells for the small bags plus the amount of large bags he sells needs to be what to 60?
Greater than or equal to.
Good. It also needs to be greater than or equal to 60. Remember, X represents the number of small bags, Y represents the number of large bags sold. So I'm going to do the math for you here to rearrange this. So the first one here, when you rearrange, it becomes Y is greater than or equal to negative 2/3 X plus 50. And this one over here becomes Y is greater than or equal to negative X or negative 1X plus 60. And we're going to graph both of these inequalities on the same coordinate plane. Okay? So I'm going to do this one in red, and I'll do this one in blue. So let's talk about how we're going to make our axes. So can I just go by ones here? No, we're going to run out of room, so I'm going to go by tens on both axes. I'm not going to write it all the way up, but you get the gist of it. We're going to go by tens, okay? Now, the x-axis represents what value? Small bags, right? And what does the y-axis represent? Good. So I'm going to do the one in the red first. So that starts at 50. 1, 2, 3, 4, 5. And I go down 1, 2, and over 3. And then I connect this with a solid line because the inequality has an equal sign underneath. And the alligator is eating the Y, so I shade above. So now for the other one, my y-intercept is 60, which is right here, and my slope goes down 1 over 1. I connect them, and it needs me to shade above because my alligator again is eating the Y. So it's a little hard to see on this one because it's so tiny, the way that they're really close to each other. But basically, we have this little pink region here, and we have this little blue region here. And then we have the white, which is everything here, which means you didn't sell enough. And then up here is anything that would fall in that category. That would be enough. So what you're going to do is you're going to choose two values that would work. Well, if they sell 60 small bags, 30, 40, 50, 60, and 20 large bags, that's enough, right? It falls in this region. So that would work. So 60 small and 20 large would be fine. What's another amount that would be fine? Anyone know?
80-10.
Good, 80-10. So if I go over 3, 4, 5, 6, 7, 8, and then up to 10, that would work too, good. So 80 small and 10 large. What if they didn't want to sell any large at all? Is it still possible? Yeah, what if we sold just 80 small bags? Wouldn't that be enough on its own? Yeah. So does everybody understand the concept of this? Alright, cool. So